Welcome to the Rich Report, a podcast with news and information on the world of cloud computing. Today, my guest is from ProfitBricks. We have Bob Rizeka. He is the CEO of the company. Bob, welcome to the show today.
Thank you very much, Rich. It's a pleasure to be here.
Well, great, Bob. Well, let's get started. I mean, the little situation here, you're part of a much larger company. How did this get started?
So I have two very good friends, Andreas Gauger and Achim Weiss, who are from Germany. And I've known them for about 10, 15 years. And the two of them built one of the largest hosting companies in the world, a company called 1&1. And they had built that up over the last 10 years to about $2.5, almost $3 billion a year in sales. And they left the company 4 years ago, took a year and a half off, and then they started ProfitBricks just about 2.5 years ago. And they started the company, and one of the main markets for cloud computing or high performance computing is really in the U.S. They gave me a call and said, Bob, here's what we're doing. It's a space I'm incredibly interested in and I think is a huge future. So I joined up with them, and I run the U.S. side of the business, and they run the rest of the world.
So you guys do infrastructure as a service, right? Is this about?
Correct.
Yeah. So this is HPC in the cloud?
Yes, it is. It's more than that, but the focus as we go through this is really around what we're doing on the HPC side of the business. And when I say that, I'm talking about really big instances, really high performance, huge network flexibility, and wrap that all together, the ability to deliver high performance networks in the cloud. And I'll go into more detail, but that's sort of it.
Okay. And I'm just before we get started, Bob, would you say it would be fair to describe it? Did you guys see a gap in the market or a need that wasn't being fulfilled, or what was the driving force there?
Yeah, well, that's exactly it. If you think about it from our perspective, people moved to the hosting market some years ago, traditional hosting market, and then cloud computing came along. But really, the founders of ProfitBricks, Achim and Andreas, looked out 2.5 years ago, and they said, we understand first-generation cloud, but really we think there's a way to do it better, a way to do, if you will, infrastructure as service 2.0 or cloud 2.0. And that's really what ProfitBricks is centered around. And from the high-performance computing perspective, if you think of big data, all the analytics, the costs involved in running high-performance computing, it's really about addressing those issues in a sort of second-generation cloud way. And that's what we're about. And that's what I'll talk about.
Well, terrific. Well, hey, Bob, I brought your slides up. Why don't we start from there, and we'll do a Q&A at the end.
Okay, great. So, Rich, if you go to slide 2, I talked about the two founders. The founders actually have funded the majority of the business. 30% of the fundings come from a company called United Internet, which is a $3.5 billion web products company out of Germany. They were actually the final owners of 1&1, so a very tight relationship with the two founders. And we started the company 2.5 years ago. Today, there's over 100 engineers in Germany alone from 17 nations. Actually, our common language is English in the company. And we have over 25 people in the United States. So we're growing pretty fast. And we went from sort of zero with the idea to building the product to launching the first generation of it in 2 years. We launched about 6 months ago in Germany and the United States. And today we have just about 1,000 customers coming online right now. And we're doing a lot of work in the high-performance computing arena. So if you look on slide 2, one of the things you'll see is a graphic. And you'll see RAM and cores with a sliding scale on that slide. And when we think about high-performance computing, it's really large instances with very high performance and complete flexibility. And I'll go into that more. If you go to slide 3, I'm just going to take a step back for 1 second. When you look at cloud computing 1.0 or our competitors where they are today, we think that, one, it's relatively low performance, relatively small instances. They're forcing you into set packages. And they're doing most of these things because they're trying to change the economics and make cloud computing work. And when you go through that process, you have a lot of issues to make it all work in a profitable sense. And that's what sort of held them back. That's why they have the small instances, low performance. So we looked at that and we said, well, there's a better way to build the second generation cloud computing. That's sort of slide 4, right? Well, slide four is really more about what I just said, how first generation cloud computing caused people to be sort of locked into set requirements, set sizing. And by the way, that really comes because in first generation cloud computing, what would happen is the infrastructure providers and my competitors, they buy 4 or 6U servers and they load them up with cores, they'd load them up with RAM, and they'd load them up with storage. And so if someone came in and said, well, I want all the storage and only 2 cores, and they sold that to a customer, that might be great for the application, but then the next guy who went in to buy RAM and cores would have no storage in that set container. And so they wouldn't be able to service the second customer. And so they came up with the whole idea of instances, and sort of relatively small instances, so they could fill lots of people on a server. And then they bought lots of these 4 or 6U servers, and they built out their infrastructure. And that's really what caused the problems. In second generation, if you go to slide 5, what we've done is we've said, to begin with, we're going to use different back-end technology, and I'll go into it in later slides, but essentially we use InfiniBand, which runs at 80 gigabits per second, versus today the most infrastructures run at about 3 to 4 gigabits per second. But by having the 80 gigabits per second, it allowed us to separate the RAM, the CPUs, and the storage so that we can have much greater flexibility and much higher performance. And I'll go into more later, but essentially what that allows you to do is offer people in the high performance computing space completely flexible networking capability, the ability to build any instance, any size that you want. So if you really want huge amounts of storage and a little bit of CPU for some tests, or lots of CPU, and I'm talking 64 cores and a little bit of storage, a little bit of RAM, you can build it exactly what you want for the application you need. So big instances and customized. Our competitors, for the most part, you can get 24 gig of RAM, maybe 36 gig of RAM. You can get maybe 24 cores. Maybe you can go a little bit more than that than 24, but they all sort of top out. With us, you can tie servers that have 64 cores together across 80 gigabit back-end InfiniBand infrastructure, and you can really create giant clusters that are connected with high speed. So you get that high performance networking, and we actually bill by the minute. So it's true utility computing. So you can imagine some of these big data issues. You're really trying to run stuff for a set time at very high performance, and then you don't need it. So a lot of our competitors in first generation will charge you by the day, by the month, or they make you lock into 3, 6, or 1 year packages, right? And you have to use a set amount. We don't do any of that. It's no contracts. It's by the minute. There's no discount for buying 6 months commitment or a year commitment. We have the same low price, however you use the product. And by the way, we are, if you look at the top guys in high-performance computing that are trying to do that online with cloud computing, we are the least expensive and by far the highest performance players out there. And that really comes because our founders, built infrastructure that was global hosting infrastructure that had hundreds of thousands of servers, right, and were very automated. So you see on slide 5, my last bullet point is this graphical data center designer. It's a big difference. What we said is with network flexibility, we want people to easily design the network they want to go use. So if you go to slide 6, you'll see that we have this InfiniBand backend network at the 80 gigabits per second. And, you know, I gave a little bit too much credit to the first generation guys. I said they ran at sort of 3 to 4 gigabits per second. The truth is they run at sort of a half to 2 gigabit per second, you know, a half gigabit to maybe 2. And what we're doing is we're running the 80 gigabits Ethernet, right, and then layering everything on top of that. And it's a full mesh redundancy architecture, so you don't have to worry about any of the technology going down. Everything else is fully online, and you can bring additional performance online as you want. And then we said, well, we have to do some really interesting things, and that is, you know, the thing about high-performance computing, you're going to want to scale up as suddenly you want to try new data sources or different size instances. We allow you full flexibility and freedom in the networking configurations, and then we allow you to, in real time, with what we call live scaling, add CPUs or add RAM or add storage. In other words, you don't have to shut down any of your instances. You can just add it in real time, and the instance or the clusters will take advantage of the added performance. So we think that's a big deal. If you go to slide 7 for a second, you'll see our data center design tool. One of the goals here was, how do you make it really easy to build an instance or to build a set of clusters? And how do you make it easy to layer the front-end servers connected to the internet and maybe put your data behind some load balancers or firewalls and really shut certain things off from the internet? So if you see in slide 7, you have access to the internet with the load balancer with a couple different servers. They have different storage. You have different private networks connected into that to other load balancers, to servers in that back end that might have some firewalls and then storage behind that. So you can really add flexibility. If you go to slide 8, I know we talked about it briefly, but it's again down to, in the top competitors, our goal here was, if we use revolutionary technology, and again, InfiniBand is just one of the technologies we use, we thought we could significantly change the metrics, significantly change the cost structure, and that's what we've done. And you'll see that in what we call the fair and clear pricing model. It's lower than our competitors, and you don't have to sign up for long-term use or certain commits to get that. We also give you full free networking. Right? There's no charge for traffic within the data center or I/O, and we think that's also very different. We've done a bunch of research with people, and as we've done that, you know, what we've seen is that we've cut people's costs by 30 to 40% compared to our competitors in the high-performance computing space, which we think is a big deal because, you know, the data is just getting larger, the needs are getting larger, and your customers don't want to pay more. I mean, not our customers, but the end customer of our customers don't want to pay more for the results. And so we're help driving down the cost. If you go to slide 9, we actually hired an outside firm, Cloud Spectator, to do an independent performance analysis of the space around high-performance cloud computing. And they actually released a report in June, July of this year. They did their analysis, and they released it. If you go to slide 10, you can actually see the detail of that report. And it's some pretty amazing performance metrics around ProfitBricks. From an overall Unix bench perspective, in the report, we asked them to look at Amazon and Rackspace compared to us. You know, we were 1.5 to almost 2 times higher performance from a Unix benchmark perspective. From a D-bench perspective, we were 8 times better than Amazon and 3 times better than Rackspace. By the way, all for a less expensive price, for more network flexibility and larger instances. If you look at the iPerf measurement, and you can go to slide 10 or look at slide 11, you can actually see the graphic. We get a score of 5,754 against 289 for Amazon's 397 for Rackspace. You know, you're talking about a 15 times performance comparison. And that's really because we were designed, right, with big data, high-performance computing in mind. We believe we are the performance leaders in the space. You know, on slide 12, we tried to add an example of one of our customers. and this is a company that has very intermittent high-performance computer needs. So you'll see one of the last statements on the right-hand bottom side. We may add 1,000 users overnight, and suddenly they need to do runs that consist of 6 hours, and then they're offline. And then they're doing big analytic spikes throughout the month. They come on, they pay by the minute, they add numbers of servers, build very large high-performance clusters, and you can see their environment, and then they're off. And they're literally only paying by the minute for that. We cut their costs by actually 70% over what they were doing before working with us. There's a lot more to talk about, but at a high level, I just wanted to cut through that and give you a brief overview of the business and how we compare in the space.
Well, thanks for that, Bob. Coming from the supercomputing space like I do, it seems like high-performance computing as a term is merging with all this big data and enterprise stuff. So I wanted to ask you, when you talk about high-performance computing, are you talking about scientific simulation? Is that part of the mix, or are you talking more about big data analytics that would run on this infrastructure?
So I'm actually talking about, you sort of touched on, but I'll call all three aspects. We have guys doing really big high-performance computing with places like MIT and other national laboratories that just need very high-performance computing. We have the enterprise guys that are running big data, and an example of that is we have some guys running math applications from some very large companies for their enterprise environment and figuring out really core enterprise management issues and analysis for customers. And then we just have fundamentally enterprises running their core business on it that have spikes of high performance and are trying to do the basic analytics, right? And they need to scale way up and scale way down. And the issue is, traditionally when they want to scale way up for performance, they're told that's easy, just create lots of small horizontal instances. But the problem is if you run on an older database or traditional database, you just can't scale horizontally like that. You don't get the benefits as opposed to scaling vertically. And that's really what we do. We have the huge benefit of being able to scale vertically for traditional databases or ease of use, or scale horizontally. And that's really where we see the high performance computing need, sort of in all three categories. It's sort of like a democratization for everyone.
Yeah.
Right? Everyone has access to it.
Sure. So when you get into big computation in the cloud, the problem always arises that you've got to move the data there and move it back across a network. How do you guys handle that challenge?
So that's a great question, because actually as we've launched and really dived into it, we've gone through multiple iterations of how we've done it. So our primary data center is in Las Vegas with a company called SwitchNet. So we do a couple things. We have high-speed connections in, and sometimes our customers will have high-speed connections and they can load it. And literally sometimes they send their hard drives in, and we send the hard drives to the facility and get all the data loaded up and let them run. Both ways. So
FedEx remains the highest bandwidth way to move data in the world, right?
Well, it's funny. You keep thinking you get higher speed data connections, it'll soften up. But we had one customer who started with us and said, look, let me do this trial. I have 5 terabytes of data.
Mm-hmm.
Terabytes of data. And then he was saying, well, okay, that's good, but now I want to ship you 20. And by the way, in 3 months, I think I'm going to load up 60. And every month they want more and more space. So no matter how fast your pipe gets, you're right. FedEx with the disk still is one of the key delivery cycles, and I think will be for a long time to come.
So, Bob, I wanted to ask you, traveling in the circles I do, there's still a lot of people that wave their hand and go, bah, HPC will never move to the cloud. Do you find yourselves having to overcome that objection, or are you more dealing with folks that are seeing the light already?
Well, I think it's a combination, but, let me give you a quick background on myself. This is my 5th startup I've done, and I've sold a company to Juniper, a company to Yahoo, and some other companies. And In my last company, I had 60-plus engineers, and I spent about $4 million on our own internal testing facility, development and test. And I've seen it when we did ProfitBricks, where we outsourced and brought our costs way down instead of having to do all that test and development in-house versus using cloud computing. We use our own stuff today. And what you see is big data is growing at such a rapid rate that you just can't really keep up with the costs, right? You're just not going to keep it in-house. It's too complicated. It's growing too fast. The technology is changing too rapidly. And most people I see are converting over, right? Business users are driving the needs, and they're driving people to convert over.
So I guess kind of a wrap-up question here, Bob. How easy is it to kick the tires on this and see if it's right for my application and my workload?
So it's really easy. If people either come in on our chat or give us a shout or just sign up for a trial account, one of our sales guys will get together and you can get a small trial account, or if you want to do a larger test, you just sign up with an account. Our sales guy will call you, and he can set you up almost any size you want to go try it. Our view is we're very different. We're the next generation, and you need to let people see what's available out there. And once they see it, they want to stay with you. So for us, it's a good deal to let people try.
Okay, terrific. Well, Bob Rizeka, I want to thank you once again for coming on the show today.
Hey, thank you, Rich. Really appreciate your time.
You bet, you bet. Okay, folks, that's it for the Rich Report. Stay tuned for more news and information on the world of cloud computing.